This is Caleb Unger and Nick Losi with ENGI460 and the first homework, and we're going to solve the problem you see on the screen. So this is the problem that we were given, and the way we're going to approach it is first substituting y over the square root of 2 in for x, and then balancing the integrand appropriately in order to take out the standard normal distribution, which its cumulative area will be 1, so it won't affect our result in any way. So that is the standard normal distribution that we're taking out. And then from there we have to balance out our g of xy equation, and as you can see, we substituted the y over square root of 2 in, and we balanced accordingly, having put the square root of 2 pi over the square root of 2 in, and that simplifies to our estimated value of square root of pi times the function you see on the screen. So the code that we use to do this, we have MATLAB solving the integral first, and then we're comparing our result of 1,000 iterations to that. And so you can see we use the estimated value equations over 1,000 iterations to give us our confidence intervals for the result. And as you can see, since we didn't have a ton of iterations, the result is not exactly the same as the result MATLAB gives, but it is really close if you look over in the right-hand corner of the screen to see the confidence interval.
Alright, so we're taking a look at another Monte Carlo simulation problem here. Again, the 95% confidence interval. So we went ahead and took care of one step, and we did a U sub for y minus 1 for z. So in this case, we're looking at a double normal standard distribution, and we're taking out the g of x again. So the goal is to have an estimated g of x function. So now this is our code, very similar to that of the previous problem, except we're doing the double integral. So we have two from negative to positive infinity. So again, we have 1,000 iterations taking of x and z, and then we're taking out here on the bottom case for mu and sigma, we're utilizing the g of x function. These are our results for the 95% confidence interval, and so those are just two examples of Monte Carlo simulation for how you can use MATLAB programming to simulate the area under a curve. Thank you for watching.